Okay, so one thing, let us try to understand the derivatives of composite functions. Now, composite functions, how do they look like? We had discussed this in, yesterday also. So, I call them pregnant functions. Why do I call them pregnant functions? Because there is a some function, and then there is a, the function also has a function in its stomach. So, what I'm trying to tell you is that, for example, let me take a function like sin x. Let me take a function like sin x. Now, sin x is a normal function, but if I take a function like sine of root x, now this is the mother function has this baby function in its stomach. Is it making sense? One thing.
Yeah. Yeah.
Now the issue is that if y is equal to sin x, and somebody asks me the differential of y, the differential of y dash would be cos x. Are we okay?
Yeah.
The problem becomes if y is a sine of root x. If I have to do a derivative of a pregnant function, a function which has a baby function in its belly. So what do I do? If I write this as cos root x, this answer is incorrect because what do I do with this? Is it making sense?
Yeah.
So that is why when we had had a discussion about this yesterday, we took some examples. I'll explain those examples again today. But what I want you to understand before I start going into the nitty gritty, that what is the necessity, and then of course you can ask why do as a medical student, once you have understood the differentiation of sin x as a class 11 student, if you have understood the differentiation of sin x, then sin x should be good enough. You have understood that the differentiation is cos x. Then why do I want to go a step forward, a step ahead, and even tell you that the what is the differentiation of a composite function? The problem is that in class 11 you will have a chapter of simple harmonic motion. Now this is the first equation that you will look when the chapter starts. This is the first chapter that this is the first equation that you will meet. That the displacement. I'll show you the problem statement. The problem statement is that there is a spring attached to this wall. This spring has a block, and the arrangement is lying on the floor. Avantika, have you understood?
Yeah.
Then you give the block a force towards, say, right or left, whatever, it doesn't matter. And because this block is tied to the spring, this block will start doing a motion like this. Is it making sense?
Yeah.
Okay. One thing that you can note down right now is that this spring pulls back this block with a force, a formula given by F is equal to minus kx. Just note this down. I didn't discuss this last time, but anyways, it is part of class 11th chapter, so you can note it down. So this force is called a restoring force. Restoring force. This x is it is very important to understand the value of this x. This x is displacement of the block from the mean position. Avantika, have you understood?
Yeah.
Okay. K is called the spring constant. Spring constant of the spring. Are we clear?
Yeah.
So F is the restoring force. K is the spring constant. This is part of your class 11 course.
Okay.
So it is absolutely fine to spend few minutes on this. X is the displacement from mean position. What is mean position? Mean position is the position, initial position where the block was at rest. Is it clear?
Yeah.
So we are clear about F, we are clear about K, we are clear about X, and you might be wondering about, so you haven't said anything about this negative sign. Now this negative sign is a very cute creature. It's a cute creature because when the displacement is positive, the displacement is towards right. The restoring force is negative. What this implies is that if the displacement is positive, then the restoring force is negative. Is it making sense? Due to this negative sign, is it making sense?
Yeah.
And if the displacement is negative, the restoring force automatically becomes positive. Is it making sense?
Yeah.
Is it like, it is almost like when I was, dating my girlfriend during my engineering/MBA times. So when I used to tell her that let us meet, she always used to tell me, "अरे मैं तो बड़ी busy हूँ, मैं तो बहुत busy हूँ, अभी मैं मिल नहीं सकती." And if I then I'll ignore her. मुझे भी लग ठीक है, मेरा भी थोड़ा ego को ठेस पहुंचेगा तो मैं उसको बोलूंगा ठीक है, भाड़ में. And then she'll try to contact me and say कि चल आज मिलते हैं, and I'll say कि अब भाड़ में जाना anyway. So the this restoring force is opposite to the displacement. Are we clear about this? Avantika, are we clear?
Yeah.
Okay. Now you might be wondering कि सर ये हमारी इसका और वो composite function जहाँ से हमने शुरू किया था, what is the relation? The relation is something like this. That this motion of the spring, when this chapter will come, the displacement of this block, the displacement of this block is given by this function. X is equal to a sine omega t. Abhi, we won't go into the details because we are not discussing simple harmonic motion per se. But what I want to tell you is that this is a composite function. Why this is a composite function? Because there is a sine function. Do you see the sine function? And inside the sine function, inside the belly of the sine function, there is another function omega t. In simple language, let me write this as y is equal to 10 sine 5t. So this a is a constant. This omega is a constant. The issue is that if I am given, let me not confuse you further. Let me write it like this. So compare this equation with this equation. Now, in simple words, I have a system, I have a spring system where my A is 10, my omega is 5, and T is a time. So this function x is equal to A sine omega t. What does this do? This function gives me the displacement of this block at any time t. Avantika, are we clear about this or not?
Yeah.
Right, तुझे समझ आया? Now again you might be wondering that, sir, then what is the problem? The problem is, Avantika, the displacement of the block is given by this function. What if I want to calculate the velocity of this block? When I have to calculate the velocity of this block, I'll have to find a differential of this. Are we clear?
Yeah.
When I want to take differential of x is equal to 10 sine 5t, then I understand that this is a constant. then velocity would be 10 cos 5t. The problem is I don't have any rule of what to do with this 5t. Are we clear?
Yeah.
I hope we are clear that velocity is dx by dt. Bhai, ye to clear hai?
Yeah. Yeah.
So my problem is that, the amount of calculus that I have been able to do as of date, the amount of calculus that I have been able to do till date, I have no skills to understand how to do the differentiation of pregnant functions. Are you able to understand my problem?
Yeah.
So the solution which is given to me is, ki boss, there is a theorem which is available. What they say is that if you have a function y is equal to f gx, and this is what I am calling as a pregnant function. Why am I calling it a pregnant function? Because this function has another function in its belly. Then how do you find the differential of the pregnant function? What do? You take the differential of the mama function, multiply that with the differential of the baby function. Are we clear?
Yeah.
Okay. What does this mean as per our mathematical treatment? This means that if I have a function like y is equal to sine root x, what I'll do is I'll take the differential of the mama function. Is it clear till here? One thing.
Yeah.
And then I'll take the differential of the baby function. The differential of the baby function. Are we clear? One thing I need out. One thing I need out.
No.
One thing, am I audible?
Yeah. So.
Okay. Are we clear?
Yeah.
So that is why when we were doing these questions yesterday, now I'll try to explain this, whatever we had done yesterday. So for example, sin x, so differential of sin x is cos x. This is a simple thing that we can do. Now I have a differential of sin x square. Now I understand that this is a pregnant mama function. So what do? I take the differential of the mama function first. Differential of sin x square would be cos x square. And then I will take the differential of the baby function. The differential of baby function would be d by dx of x square, and that would be equal to 2x. So this would be cos x square into 2x. The answer would be 2x cos x square. Avantika, are we clear, or is there a doubt still?
Yeah.
So,
No.
so the style is that take the differential of mama function first, multiply it with the differential of the baby function. And there are few things about differentials that we already know. I will just revise those things that we already know. That so, for example, y is equal to fx. Let's take an example that y is equal to sin x. If I have to take a differential of y dash, it will be cos x. Now, if there is a function like y is equal to k into fx, where k is a constant, an example can be y is equal to 5 sin x. Now, if I want to take a differential of y is equal to 5 sin x, what do? 5 remains the same, and I take the differential of the sin x only. So, sin x differential is cos x. If I have to take differential of two functions which are added together, it is very simple. Take the differential of the first function, then take the differential of the second function. So differential of sin x is cos x, differential of 5 is 0. Are we clear till here? These are the kind of things that we have already done. Are we clear till here?
Yeah.
If I have two functions which are multiplied together, very simple. This is the case what we had discussed in y is equal to u into v. Take the differential of the first function. Let the other function wait. Then take the differential of the second function and let the first function wait. So, for example, if I have a case like y is equal to sin x into cos x into x square, then sin x differential would be taken first. X square will just wait. Then the differential of the sin x, the differential of x square would be taken, and sin x would just wait. Are we clear?
Yeah.
We did another thing which was a bit complicated, if you remember, that if there is a function like y is equal to u by v, if you remember, we had done this also. This was a bit complicated. So here the differential used to be v square, v du, the differential of, let me write this simply as the differential of u dash minus u, the differential of v dash. Do you remember a bit, Ms. Avantika?
Yeah.
Okay. Now, what we are doing is we are focusing on this function, where mama function, baby function. This function would look something like this, sine is equal to 5x. So this is the mama function. Differential of mama function would be cos 5x. Nothing will happen to the baby function. Multiplied by the differential of the baby function. The differential of the baby function is 5, and the final answer is 5 cos 5x. Avantika, are we clear?
Yeah.
Let us try to understand this with a few more examples, and I have already told you that I need this when I'll be doing this simple harmonic motion. So during that time, I'll refer you to this lecture. Are we clear?
Okay.
Let us
Yeah.
take two, three examples more. So differential of if I am given a function like 5 sine x cube. The simple case, this is a constant. So I will write 5 here. This is mama function. Differential of mama function is cos x cube. And then multiplied by differential of baby function. Differential of baby function would be 3x squared. Is it making sense, Avantika?
Yeah. Yeah.
See, if you are not asleep as yet, you would understand that this can be written as 15x squared cos x cube.
This was the answer I got yesterday, actually.
Yeah,
That's why I was so confused.
So you could have told us.
I'm like, it's like so embarrassing to get a wrong answer in the class. So I'm
But
like,
why-
I'll just stay silent and look at him explain.
But why is it embarrassing?
I don't know. I have anxiety issues.
I keep making mistakes. This rascal son of mine keeps making mistakes. So it's absolutely fine. Not an issue.
Okay. Because you had written that 2x point cos x square. तो मैंने वो देख के I did the 15x square लाया मैंने. तो then वो कल नहीं किया था वो, so I got confused thinking I did some mistake.
Abhi clear?
हाँ.
Abhi clear?
Yeah.
Okay. So let's go to the second part. Second part is y is equal to 5 plus sin 3x. फिर से ये फर्स्ट फंक्शन है. जो फर्स्ट फंक्शन है उसका जो डिफरेंशियल है वो यहाँ लिखा हुआ है 0. ये दूसरा फंक्शन जो है दैट इज pregnant function. So first differential of the mama function. Differential of mama function is cos 3x multiplied by differential of the baby function. Differential of the baby function is 3. So the final answer would be this 0 would anyways will have to ignore. So the final answer would be 3 cos 3x. Are we clear, Avantika?
Yeah.
Okay. Let us take another example. Y is equal to sin 5x cube. फिर से mama baby function. First differential of mama function. Mama function would be किया भी है नहीं किया. हाँ ये किया. Differential of mama function would be cos 5x cube. Then differential of this 5x cube would be 15x square. Avantika, is it making sense?
Yeah.
See, अभी थोड़ा maths complicated है. You'll have to manage that. Sin 5x cube is not equal to 5x cubed sine x. Have you understood? These are two different things. Are we clear?
Yeah.
So when I say sine 5x cubed, basically, if you want to understand, you can write it like this also. Are we clear?
Yeah.
Because this is a sudden change of abstraction from class 10th to 11th. आप बहुत बड़ा change ले रहे हैं. It is like going from Bombay to Mount Everest. You know, it's a big change. It's big change in the altitude. So now let us come back to our physics problem. ये जो सब फसाद की जड़ है, वो ये है. When we have to understand this, and this is what I was trying to tell you. We will take another example tomorrow. Which example that we were discussing yesterday. उसमें फिर से समझने की कोशिश करेंगे. Because anyways थोड़ा सा complication हमें अपना we'll have to get comfortable with. Now let us come back to this. कि if in a simple harmonic motion, the displacement of a block is given by x is equal to a sine omega t, how do I find the velocity and the acceleration function of the block? This is part of your class 11th syllabus. So velocity would be given by, this is a constant. So because this is a constant, this will wait. I will take the differential of the Mama function first. The differential of Mama function sine would be equal to cos omega t. Are we clear?
Yeah. Yeah.
And then I multiply that with the differential of the baby function. The differential of the baby function would be omega. Are we clear?
Yeah.
If there is a doubt, you can write this as d by dt of omega t. Because omega is a constant, इसलिए omega ऐसा ही रहेगा. And dt by dt जो है वो 1 हो जाएगा. That is why the answer is omega. Are we clear?
Yeah.
Let me try to explain this with this example that if x is equal to 10 sine 5t, then velocity is equal to 10 into cos 5t into 5. Are we clear?
Yeah.
Why? Because the differential of this baby function is 5. And this 10 is my constant. Are we clear?
Yeah.
So, see, things are not simple. I understand. See, this k is my 10. Have you understood? And that 5t is my gx. Have you understood?
Yeah.
So that is why this k just waits outside. Just wait outside. Are you clear?
Yeah.
So if I am given a spring whose displacement function is given by this, then the velocity function would be given by and the acceleration function would be given by is it making any sense?
Yes, sir.
Bit complicated, but don't worry anyways, when this chapter comes we'll be discussing this. But I just, because I want just closing this calculus part, that is why this is a very small topic, but I wanted to discuss this also. So that is why if you see, this acceleration function is a differential of dv by dt. I have my velocity function this. Or here if you see, this a and omega are both constants. And that is why this a and omega are waiting out. And the differential of cos omega t is minus sine omega t. This is the mama function. This is the mama function. This is the derivative of mama function. And the derivative of the baby function is written here, omega. And the whole derivative is minus a omega square sine omega t. Are we relatively clear? I understand that this is confusing. But compared to yesterday, are we relatively clear? Mr. Vantika?
Yeah, sir.
So if the displacement function is given by this, the velocity function is given by this, and the acceleration function is given by this. This is the direct application of composite functions in your physics in class 11th. Are we clear, Mr. Vantika?
Yeah. Yeah.
So theoretically, that is all that gyan that I wanted to give you today. And if you want to do practice problems, this lecture, I have sent you this lecture, differentiation of composite functions. There are lots of short problems are there, and it will help if you can solve few of the problems that are being discussed here before tomorrow's lecture. So if you see, I've taken few examples. So it's a good lecture. You'll understand this. Because the problem is, I'll tell you the problem. So for example, in chapter number 3, if you see, once your this force and everything starts, force and vectors, etc. starts happening in chapter number 3, there'll be this a question like this, that the displacement vector of a particle is given by so and so. Find the velocity vector and the acceleration vector. This would come in chapter number 3 only. So there again, you will require this help of the composite functions. And that is why I wanted to take care of the composite functions before we start going into the details. Are we clear?
Yeah.
So please trust me on this, that nothing is out of your syllabus. You'll have to,
Okay.
trust me on this. Are we clear?
Yeah.
So let's meet tomorrow, same time.
Okay, sir.